In PSC1 Lesson 4, you will be able to define and use indirect measurement, as well as solve word problems using indirect measurement and similar triangles. Indirect measurement uses similar triangles to calculate the height of objects you can't reach. So for example, a tall building, it's hard for us to directly measure the height of a building, and so we can use actually shadows and our own height and similar triangles to figure out what the height of these objects are. There are actually two different methods to apply indirect measurement. I just briefly talked about the shadow method, and that is the first one. This works on a sunny day. If you're outside, you see your shadow, and you can see shadows of buildings and different things. And what you will do is you will create two similar triangles. So here in this picture, we can see our two triangles. We have this little triangle that is made up of the height of a person and their shadow. And we have this larger triangle, which is the height of a building and the shadow. Both of them use the same source of light, being the sun, which is why this works outside. When we go to solve for missing pieces, which oftentimes is, in this case, the height of the building, we can set up a proportion just like we learned before. So we can take this little triangle and we have side length A over side length B. Then we can use our information from our larger triangle for our other ratio. Little a, which is the height of the person, corresponds with the big A, or the height of the building, over little b corresponds with big B, because both of those are the shadows. Now you can also set this up as A over small a equals capital B over small b. The important thing is that you are being consistent. And then you are able to solve for whatever missing piece you need. Our second method is called the mirror method, and this method works indoors and outdoors. So we don't necessarily just need a day that's sunny outside. We can use this anytime. How it works is you place a mirror on a level spot, a distance away from the object, and then you, as the person, back away from the mirror until you can see the top of the object in the mirror. These two triangles that are created are then similar. Okay, and so you can see here we have one triangle here, and we can call this the height of the person A, the distance away from the mirror B, and then we have our second triangle, which is here, and the height of the object we can call capital A because that corresponds with the height of the person, and then our distance away from the mirror would be our capital B because that corresponds with little b. And again, we can set up our ratios. So I can use a small triangle. I can say A is to B as, using my larger triangle, capital A is to capital B. Again, just like before, I could do A over little a corresponds with capital B over little b. You just need to make sure that you are being consistent. And then you can, again, solve for whatever unknown. Typically, it's the height of the object. Let's go ahead and look at our first example. You are at an indoor climbing wall. To estimate the height of the wall, you place a mirror on the floor 85 feet from the base of the wall. Then you walk backwards until you can see the top of the wall in the mirror. You are 6.5 feet from the mirror, and your eyes are 5 feet above the ground. How tall is the wall? Step 1 is always to highlight important information. Step 2 is to draw a picture. So let's say, for example, we have our wall, which is right here, and we have our mirror, which is right here. It says that from the wall to the mirror, that is 85 feet away. We, or you, are right here because you backed up away from the mirror, and the length from the mirror to you is 6.5 feet. Then from your feet to your eyes, we find that that's 5 feet. We can go ahead and create our similar triangles. Now that we have a picture, we are ready to set up a proportion and solve for our unknown. So here we're trying to find the height of the wall. I know that we have 5 is to 6.5. That is the height of me, how far away we are from the mirror, is equal to our unknown height over 85 feet. I know that my 6.5 corresponds with my 85. I know that my 5 corresponds with my h, so I've set my proportion up correctly. And now I can go ahead and just solve. So 5 times 85 is 425, which is equal to 6.5 times h. I can divide both sides by 6.5, and I get 6.3846. Let's round to the nearest tenth. So 65.4 feet is the height of the wall. It's always good to think, does that make sense? And as we look at our numbers, it does make sense. So just a reminder, read the problem and highlight. Step 2, draw your picture. Step 3, set up your proportion. Step 4, solve. You will do this for all of your indirect measurement problems. In example 2, our picture is given to us, and the question asks, how tall is the Eiffel Tower? Here you can see they're using the mirror method. I'm going to set up, I can see my small triangle and my larger triangle. I can see I have 1.5 is to 8 as my height, which we don't know, is to 1728. So we can set up that proportion, again, making sure we're being very consistent. And then we're going to go ahead, cross multiply, and solve. So 1,728 times 1.5 is 2,592, which is equal to 8 times x. Divide both sides by 8, and we get x equals 324 meters. With all problems, make sure that you read carefully, you draw your diagrams, and you solve for the unknowns.